Okay, now that we've got the first implementation of the Canon game complete, I promised as we were working our way through it that we would revisit the two utility methods that we had created where I could explain to you on a whiteboard exactly what was taking place inside of those methods. Remember, we had GetCenter and we had distance. Now, I did not want to break away to a full whiteboard discussion while we were coding the game for the simple fact that it would disrupt the flow. Anyone that was trying to follow how all of the methods kind of interlocked and worked with one another would get confused or simply start to forget what was taking place, and we did not want that to happen. We wanted to keep the big picture as clear as possible while we were working in all of the intricacies of the methods. Now, we can focus on these two utility methods one by one. Let's start with GetCenter. Now, how does GetCenter work? Well, here we are over here with basically, remember, it was a private GetCenter returning a point, and it took in a control. So here's our code for it. It's just pulled straight out of the game and pasted right in here, so it's dead on. So here's what I want to focus on. So basically, we're returning a point, and remember, the point needs to be the center. Now down here I've got an object that's going to represent the target or the projectile. It doesn't matter. The idea is that we can send some control into GetCenter, and GetCenter is going to tell us where the center of this control is. Because remember, everything we work with in regards to our visual controls on a Windows screen is basically all based off of left and top properties. That defines where it's sitting on the screen. But with what we were dealing with, we needed to know center locations because we needed to calculate things like the distance between two of these visual controls. So we need to convert this left and top piece of information into a center X and Y coordinate for the particular object. So again, here we've got a very simple object setup. Pretend this is our target. It's just red instead of white. Now what I'd like to do is go ahead and remind you guys of some of the basics here. So this right here is going to represent our left. And let's go ahead and give it a value. Let's say that this particular visual control, this picture box if you will, is 20 pixels over in X on our application. The next thing that we have to deal with is going to be top. So let's go ahead and just mark that out real quick. And top simply controls how far down the screen it is. So here we are with top. And let's give it a value, I don't know, maybe something like it's 30 pixels down. Now we need to define a width and a height of the control. So let's go ahead and come over here and say that our width is, and I'm going to pick on some very simple numbers. Logan, I know we were using 32 by 32, we were using 8 by 8 for the projectile, but let's just do something like 10, just to make the math as simple as we possibly can. Okay?
Not only that, the method is meant to work on a control that has any width or height.
Absolutely. And 10, and we'll do 10 for the height. All right. So what do we need to do? We need to define the center. And that is what gets returned. So where is the center? Well, let's just look at it. Now that we've drawn it out on paper, let's not even think about the formulas. We know if we happen to be at the moment 20 units over, and we know that the width is 10 units, that means the other side over here is going to be where? It's going to be at 30 pixels over, okay? Where would the center be? Well, right between 20 and 30. So we're looking for what's going to end up being 25 in X. It's going to represent the midway point along the X axis, if you will, of this particular object. Now let's do the exact same thing for the height of it. So we know that it's 30 pixels, that's where it starts, and it's 10 pixels high. So that means down here would be what? 40 pixels. So between these two would be what? Well, between, it's quite simple, 30 and 40, we're going to have 35. So we're looking for 35 right here. So just by visually looking at this, we know the answer that we should be sending back is going to be 25 in X and 35 in Y. This right here is the center of our control. C-E-N-T-E-R. That's right. I can spell, I promise. So now let's take a look at how the formula is working so that you can kind of put all the pieces of the puzzle together. We first start out up here with the control dot left. So let me jump up here and say C dot left. And what was C dot left with the little example that we defined? It was 20. Okay? And then we said plus C dot width. And what was C dot width? We defined that as being 10. But now check it out. We've got over here C dot width divided by 2. Now, we've talked about operator precedence. The division operator has a higher precedence order than the addition operator. Now, to make this a little easier to see over here, I'm going to do a divide by 2 so that we've written out the entire formula. But now, I'm going to put parentheses around these just to help make visualizing this a little easier. So we're going to take this 10, which is what is in C dot width, and divide it by 2. So what is 10 divided by 2? 5. Let's bring our 20 down. So now we've got 20 plus 5. So if we take this, solve it, we simply have 25, and we're figuring for left. So that means we're dealing with x. So this is x equals, so check it out. We've got 25 right here. We've got 25 that we're shooting for, that we know we should have. And if we look over here, when we pictured the whole thing mentally without actually using a formula, we got 25. That's the halfway point. Now, bringing our attention back up here to the code, this first section is returning x. All the way over, the formula stops at the comma. That's the end of this compound expression. Now, the comma separates the x and the y in the point. So now, the next thing we're going to solve for is the y portion of our point, which is this guy right here. So let's go ahead and work it out. We've got C dot top plus, now what is C dot top? All right, again, in our little example, we said that it was 30. So let's go ahead and put 30 in. Okay, C dot top plus, now we're going to do C dot height. Okay, what was C dot height? Well, we said it was 10, so let's put 10 in there. So there goes our 10. All right, and I probably shouldn't talk with an accent like that, even though I thought it would be fun. All right, so then we've got 10, and what are we going to do with 10? We're going to simply divide C dot height by 2, and again, to help visualize this, I'm going to come in here and throw parentheses around it to say, hey, remember, this is getting done first. Do the parentheses have to be there? No, they don't exist in the code that we've got. If we had put them in the code, would it have caused a problem? No. I'm just helping you visualize what is happening. So this is getting solved first, once again, because of operator precedence. So 10 divided by 2, here goes some of that really complex math again, is going to give us what? 5. Now we've got, if we bring down our 30 here, we've got 30 plus 5 equals 35. And you guys thought I was going to give you some challenging mathematics. Now we're dealing with the top here. So this is basically our y. Well, not basically, this is our y. So y equals 35. Well, lo and behold, look at this. 35 is in the y position. X position, comma, y position. That is the second part of the arguments that's going on right there for point. Okay? So there you go. X and Y. Logan, is there anything you want to add to this?
No, I think that pretty much covers it. Again, the only point I'll reiterate on is that we did not put parentheses in the actual code because we were simply leveraging the order of precedence.
That's right. Where multiplication and division is definitely going to take place before addition and subtraction. So that allows us, with this method, to send any control over to GetCenter, and we simply send it in through, let me find where my pin's at, there we go. We simply send it in right here. The control is then represented with the variable C inside, or let me say the parameter C to be a little bit more accurate. So within here, I can now talk to that particular control and find out its left value, its width, and things like that. I can then work with that information to generate a new point which contains an X and a Y. And let me go ahead and switch this over real quick. There we go. This will allow you to see what I'm pointing at. So I can then use this to generate a new X and a Y for point, and we are simply returning it. Remember, we return a point. So this is where we're sending back out an X and a Y. Okay? Beautiful. Well, that's pretty much going to be it for the GetCenter utility method. That's going to wrap up this video. Thanks a lot.